All right, hello. So in this video, we're going to go over one of the fundamental concepts in programming, like in Python specifically, but in really any language as well, which is the idea of variables. So variables are sort of one of the most basic pieces for most kinds of structured programming that we're going to be doing, and so that's sort of the place that we'll start. Okay, so let's see. So a variable is a label that's given to a different value. So it's a way for you to refer to a particular piece of information. You can almost think of a variable a little bit like a name tag or a label that's being given to some value or to some number, for example. So it's a way of saying that this isn't just the number 3, right? That's just not just the special number, but that number is actually labeled as num cups of coffee. So the way that we're going to write that is that in Python is that we would write the name of the label. So in this case, num cups of coffee, and I've got underscores between my words. So that's one word, right? Can't put spaces in there, but sort of one identifier, one label. So this is my label. And then I'm using an equal symbol for what's called an assignment operator, and then giving it a value of 3. So I'm saying that we're going to take this number 3, that value, that set of data, and I'm going to label it as the number of cups of coffee that we're drinking each day. Cool. So again, this is the way this is read, is saying assign the num cups of coffee label or name tag to a value of 3. That assignment, that equal symbol gets a little bit awkward. I've heard some people use the word gets when reading this. They might say that the number cup of coffee gets a 3, which is not terrible, which is pretty good language. But again, so that's how we go ahead and we assign a value to a variable. Once we've done that, we can then use that variable in different places throughout our code. We can use that name as sort of a placeholder to refer to that particular value. So for example, in this sort of more complex example here, I've got my value 3 and I've assigned that to my number cups of coffee. I've also then taken a number of 3.5 and I've assigned that a name tag. I've labeled it as price per cup. I've then created a new label cost, and that label is then going to be attached to the result of taking my number of cups of coffee, 3, and multiplying it by my price per cup. So what I've now done is I've used not the numbers 3 and 3.5, but I've used the numbers that those variables represent. I've said take the number of cups of coffee, whatever it happens to be, right? Whatever that label is currently referring to, and it was referring to 3 2 lines earlier, but it may have changed over time. Whatever that's referring to, multiply that by whatever the price per cup is referring to, and then take that value and label it as cost. So then we see when we print out the cost, we get our first printout line, which is 10.5, which if you do your math real fast, 3 times 3.5 is in fact 10.5. Similarly, I can then take my cost variable. I can then take my cost and multiply it by 1.5, right, in order to add 15% cost to it, in order to then get the 15% of that cost, and then add that to my current cost, right? So I can say take the cost and add to cost times 1.15, math, and then I can take that value, right, this new value here, what's happened when I took that 10.5, multiplied it by 0.15, and then add it to 10.5 again, and I can reassign that to cost. I can take that cost label and move it from the original 10.5 over to this new value that got calculated. When I then print out that new cost, you'll see my cost has now changed to be 12.075 because that's now my cost with tax added onto it. So what that then means is that we can begin moving these, we can start using these variables as sort of replacements for the actual values they represent. We're basically going to say rather than referring to a particular person, we can refer to this variable as sort of a stand-in for whatever that value it happens to represent is. Okay, let's see. So a couple things to note about this. Sorry, check my notes. So it's kind of a quirk of programmer speak that will often use the phrase assign a value to a variable, kind of like we're giving the person that name tag rather than putting the name tag on the person. So we might say we're assigning 3 to number of cups of coffee. It's almost like we're taking the name tag and putting 3 on it, but really more accurately, we're taking the number of cups of coffee and assigning it a value of 3. So the language gets a little bit fuzzy here because computer programmers, even though they're writing incredibly specific and precise programming language, don't really speak about that in a precise language instead. So we'll often use the phrase like assign 3 to number of cups of coffee, assign number of cups of coffee a value of 3, let number of cups of coffee be equal to 3, like you set number of cups of coffee equal to 3. There's sort of a lot of language used to describe this kind of operation, how this is working. Okay, so again, the idea here is that we're saying give these values a name, and then we can take those names and use them in place of those values. Now, to be really clear with this example, what's going on here is that what we're doing is we're taking everything on the right side of the equal symbol, right? That set of values, and we're actually telling the interpreter to evaluate them, figure out what is that number. So the interpreter goes and says, oh gosh, okay, cost. Well, cost at this point in time was 10.5, right? We printed out cost, it was 10.5. So it says, okay, that means, so what the computer is really doing is the computer is saying, okay, what I really mean here is this means 10.5 plus 10.5 times, doing some math here. So what the interpreter does is the interpreter is going to go ahead and replace these variables with the values they represent, and then take that result and then assign that result to the cost. Take that cost name tag and apply that name tag to whatever this number happens to be. So the idea here is that depending on which side of the name tag we're on, the word cost, like that label, means different kinds of things. In particular, what it means is that if a label is on the left-hand side of the equation, it means the variable, that word means the name tag itself, means the variable itself. When it's on the right-hand side of the equation, it's meaning the value. So again, right here, right, this is actually saying the label, C-O-S-T, cost. But on the right-hand side, it's saying, okay, this word cost here doesn't actually mean that name tag, doesn't mean like the name tag itself, it means the thing the name tag is attached to. So depending on which side of the equal symbol we're on, you're going to get different sort of meanings behind what that word cost is. Is it the name tag itself, or is it the thing the name tag is attached to? And so again, programmers play kind of fast and loose with this distinction when we're talking about things, right? So I'll often talk about the variable cost without being sort of specific about whether I mean the name tag or whether I mean the value that label is actually referring to. Often I'll mean the variable is the name tag, but sometimes the variable is going to be the value, right, the number itself. It really varies, and it can make communication really difficult. It can get hard to understand instructions and assignments. It can make it hard to understand when people are trying to explain what they did, and that's sort of a challenge. And you'll find a lot of these communication difficulties show up a lot when dealing with programming, because while we're trying to write very specific code, we're trying to talk about it in a more fairly general sense. So, that's the thing to sort of keep an eye out for, right? Don't hesitate to ask for clarification if there might be some vagueness about whether we're talking about a value, right, the number, or we're talking about the name tag, the label itself. Okay. The next important piece to note is that even though Python uses this equal symbol for assignment, for the meaning to attach a name tag to some value, an assignment does not mean an equality, right? It doesn't mean these two things are the same or they are equal to each other. It's not equality in sort of the mathematical sense. It literally is just an assignment saying, put this name tag on this value. In particular, you can see this is that when you change some value, that doesn't necessarily change other variables that might be set equal to it at different times. So as an example, if I make a variable x and say x is going to be equal to 3, right? So that means I'm going to assign the label x to 3. So 3 is now nicknamed x. Y is being assigned 4, so now 4 is nicknamed y. When I say x is equal to y, I'm not saying that set x and y to be equal to the same thing. What I am doing is I'm saying take whatever y is, because remember that we're on the right-hand side of the equal symbol, so therefore this y is really just a placeholder for 4, what that name tag is referring to. So it's really just saying take 4 and assign that to x. Let's take the label x and move it from the 3 over to the 4. So that when I print out x, I get 4. That's what's going to get printed out. But now if I take the label y and I move it onto a 5, even though I've said that x is equal to y, that's not also changing x. Because remember, I'm not saying actually change the value. Because at this point, I haven't said that x and y are equivalent. I've simply said that whatever value y is currently on, I want to put x on that value instead. But otherwise, there's no relationship between these variable names, right? There's nothing about x and y or any variable names at all that make them related to each other. Variables are just labels on particular values. So if I go ahead and move the y label to another number, that doesn't impact the X label. The X label is still on what Y used to be on. So therefore, when I print out X, it still stays 4. So again, even though we've got this equal symbol here, it's not actually giving an equality. Similarly, you can't adjust the order of these things. I can't say that I can't say 3 is equal to X. That's not actually valid code. It's not the way we write code, because that would be trying to say take the label 3 and put it on the value X. But X doesn't mean anything, right? X is equal to 3. That's how we'd have to write this code. All right, so there's one problem with this example, is that and it's like, well, syntactically, the code is valid. It doesn't necessarily explain to me what the algorithm is or why I'm doing this kind of work, right? Why is Y being assigned a value of 5, right? Why are we labeling 5 with Y? Is there a relationship between X and Y? Like, are these things supposed to be labeled? And like, what's going on? What's supposed to be happening here? So the point is that we don't really sort of know what these numbers mean. So here's another example. So here's a valid set of code, right, that does something. We're going to take 35.0 and we're going to assign it a label A. So we're going to put an A name, we're going to call that guy A. We're going to take 12.5 and we're going to assign it, call it B. We're then going to take A, multiply it times B, and call that result C. So I've given labels to all these things. And that's perfectly valid code. It all runs just fine. But what we're not seeing, or what we're not learning here, is why we're doing that, right? What's the point of this? What is this relationship between A and B? Why am I multiplying them together? Why is A getting 35? Why is B getting 12.5? There's no information in the program that tells me what's happening there. So what we want to do is we want to name our variables in ways that they actually explain what's going on and what that data represents in ways that a human can understand. So as an example, we could do the exact same program, but with better and more descriptive variable names, where instead of calling it 35A, I could call it hours. Instead of calling 12.5B, I could call it pay rate, which means that then when I multiply hours times pay rate, I understand the earnings. So you see, now I only have meaning behind this code. I understand why I'm writing these numbers and why I'm multiplying them, why I'm doing this kind of work. And I can discover that, for example, this person clearly needs a pay raise if they're only making $12.50 an hour. Because come on, right? So the idea here is that we can, by using these more descriptive variable names, we can actually be able to better understand what the algorithm of our code is, right? Not just the syntax, but what we're trying to achieve. And that's going to help us be able to understand why we're giving particular sets of instructions along the way. And that's what we want to do here. So the key here is we want to use these descriptive full word variable names, right? Write out hours, write out pay rate, write out earnings. That's fine. Don't try name variables A, B, C, or X, Y, Z, or like these single letter abbreviations. There's no benefit to writing smaller code or writing things in less typing. It saves you some typing, sure, but that's not worth it for the confusion that it adds in trying to understand what your system is. Similarly, don't try to like make anything overly complex with some other bizarre shortcuts or syntax for trying to understand what's going on with the variable names. Just give these things decent, understandable variable names that everyone can understand, and we'll be good to go in how that works. Yes, so this is not only gonna it might cost a couple extra keystrokes, but it's gonna make your life so much easier and so much better. This is, I'll just make this big here, right? I'm going to note that this is one of my biggest hangups in programming. This is like my one sort of style requirement that I really care about, right? Single letter abbreviations or vague variable names, they're considered wrong in this class. And really they should be considered wrong anywhere. I don't care what anyone else says. They're wrong. Don't be one of those people that writes, don't write the code that looks like this. Don't be a C programmer. We want to be able to write code that's understandable and we can work with, and that everything can make sense. We can make progress with that. So the second thing to note about variables is that each variable or each value has a particular type, a particular kind of data that it is. So in this lesson, we're mostly working with the most basic types, and we'll sort of introduce in more sort of as we go. But I want to sort of go through what some of these basic types are, so you get a sense for how this works. So the basic type that we've started with so far is we've worked with numbers. Python actually has two different kinds of numbers and two different types of numbers that exist in its system. It has what are called whole numbers or integers, and it has decimal numbers or what are called floating point numbers. You can see this if you use the type function. So you're going to type and then in parentheses put then a particular value. You can see what kind of thing that is. So if I say what type of thing is 7, I can take that result and assign it to type of 7. If I then print that out, I'm going to hit Shift Enter to run this, it tells me this thing is of type integer, right? It says its classification, the kind of thing it is an integer, an int. Alternatively, if I say what type of thing is 3.14, it tells me that is a class that is a float. It is a floating point number. They're called floating points because the decimal point is floating around inside the numbers. So hence it's a floating point number. So Python actually keeps track of these different data types, these different kinds of variables. And the reason this matters is because different types of variables do different kinds of things. So for example, right, I can math numbers. So numbers can be added and done math upon them. I can add them, we can multiply them. But you might see some differences in whether they're whole numbers or decimal numbers about depending on whether we do things like division. Or when we do some operations, you'll see some of these kinds of behaviors that shift around as you're doing different kinds of operations. You'll often see, let's see, I'm trying to think of a specific example. Okay, so, right, so if I take, for example, if I take 3 plus 4, right, and I run that, then I get an output of 7. But if I did 3.0 plus 4.0, now I'm working with floating point numbers, you notice that my output, my result, is also a floating point number. It has a decimal point in there. So this gives us different levels of precision, different levels of details, and those things are stored in the computer in different ways. Now, the thing you have to kind of keep an eye out for is that in general, computers are really good at working with whole numbers, and they're really bad at working with floating point numbers. Because remember how computers, they only speak binary, which doesn't actually have decimals involved in it. So if they want to represent decimals, they do that in kind of a weird way. So what that ends up meaning is you can get some slightly odd behaviors. For example, if I take 5.1 and I subtract 2.6 from it, and I hit Shift Enter, then you'll notice that I don't get 2.5 like I expected. I instead get 2.4999996. So I get something that's almost 2.5, but not quite. The reason for this is because the Python doesn't actually store floating point numbers in terms of decimals. So it does not say that this is 5 wholes and 1/10. Like, it doesn't read it that way. What it actually stores this as is using some complex exponent structure, because that's how computers are structured, how computers are sort of designed to work with floating points. And there's a really bizarre system that we're in no way going to go into. But what it does mean is that when you then try to subtract this, it can't do basic, like, second grade algebra, math or whatever, when you're actually going to be like, let's carry the 1 in order to make these things work over here. Instead, what it's going to do is it's going to use this other kind of complex math, so you end up getting these rounding kinds of errors. So for that reason, I strongly recommend that you do all your work in integers, in whole numbers, as much as you possibly can, and only move to decimals if you really find yourself sort of like requiring to get that level of precision. You'll actually tend to find better, more accurate results if you're working with integers sort of the whole way through. The second kind of data type that we're going to work with a lot are called strings. So strings is the word we use to describe text or words of different kinds. So they're called strings because they're considered to be strings of characters or strings of letters, where a character can be a letter, a punctuation, or a symbol, or anything else. You can write these in either single quotes or double quotes, but anytime you write some words inside of quotes, that means that it's a string. And again, you can think of it as like a string of letter beads on a string. So the idea is that we can then use these, so we can be able to write down code, right? We can write down text inside of quotes, and that makes into a string typed variable, right? That's the kind of thing that's not a number, it's text. Strings can include any punctuation. They can include spaces. That's considered part of a string. It's a character. From a computer's perspective, a space is no different than an A or a B. It's just another symbol. Similarly, punctuation like colons, exclamation points, those are all considered strings, or there are characters that are all considered parts of a string. If you want to put quotes inside of them, you can put single quotes inside of double quotes or double quotes inside of single quotes. That works fine. So you can put single quotes inside of double quotes. You like, so for example, saying I'm Joel. You could also put single quotes or here. So here's a B string. You can also then put he said hello, right? Double quotes inside of single quotes. That works fine. If you want to try to mix and match these, again, these are variable names, right? You can do, like, for example, he said, oh, stop. I'm Joel. You'll notice that when we try to write that, then what happens is that and you can see this from the coloring of the interpreter, is that Python sees this quote, this ending quote, and says, oh, that must be the end of your string. That's the end of your text. And then you just have this extra I after it and doesn't know what to do with that. Doesn't know how to interpret the writing some text and then have an I come right after it. So what we can then do is you can either, if you're trying to then mix these things together, what you can end up doing is you can use what's called a backslash, which is it's not the forward slash, it's the backslash, right? The one that sort of looks like it's falling backwards from an English perspective, I guess, or, got its feet out. And what that does, that's what's called an escape characters. And that basically says that treat this thing, don't give it a special programming meaning where it means like end of string, let it just be its own normal piece. And then you'll notice that then I can write my own piece, my own, he said I'm Joel, and then if I print out my C string, right, it prints out I'm Joel just fine. Oh wait, but I need to close off that quote. So I will put an escape there, and then I can be able to print out I'm Joel. So if you want to be able to handle quotes inside of strings, you can do that as well by, again, using this kind of escaping characters. In Python, you're also able to do some operations on strings. In particular, you can add them together in a process that is called concatenation. Concatenate meaning to like hook together. So that's sort of a complex $2 word that's used for meaning adding strings together, right? Combining them together. So for example, if I take greeting and I can say take the string hello and then add it, combine it with a string that's just a space, and then add it to the string that's world. If I then I'm going to then take all of that string, that value, label it as greeting. If I then print out my greeting, then my greeting is hello space world, right? I've taken those strings and I've concatenated them, combined them together. However, you'll find that sometimes you'll have some problems with this if you try to concatenate strings and numbers. For example, if I'm trying to come up with our course number and I want to say this is LIS511, if I try to say take LIS and add the 511 to it, if I hit Shift Enter to run this code, you'll see that I get an error. And so this is what errors look like in Python. There's another detail that has some more details about how errors work in Python, how to handle that. But you'll see that this is giving me a problem, right? It gives me this whole type error and big red block and tells me where the problem was. It says the problem happened at this line of code right here. And it says the error was I can only concatenate strings, not integers. Python is not able to take a number and add it to a string. It doesn't know how to hook those things together. Like they don't fit. It doesn't know how to work with those pieces together. This is because numbers are distinct types than strings, right? If I say what type of thing is 511, it tells me that's an int. But if I say what type of thing is 511 inside of quotes, that thing is a string. And those are different types. I can't add numbers and strings. Just like you can't add apples and oranges, you can't add numbers and strings together. So what we're going to end up doing is we're going to take, the way we end up doing this is we'll end up taking our numbers and we need to convert that number into a string in order to concatenate it onto anything else. So what I can do is I might take my number, 511, and I might, for example, give it a label called course as a number. I can then use a function called string. So I type str with parentheses after it. And that will then let me create my string course as a number. So I can take that 511 that was a number, and I can basically make a string version that gives me my course as string. So when I run that together, if I then say what type of thing is my course as string, right, that's a string. So that works. Which means I can then, of course, say that my course can be equal to LIS plus my course as string. And then print out the course. And then it works out just fine. Everything looks the way we want. So to be clear, so this string function, str, is what lets us convert from numbers into strings. But we only need to do that if we're actually trying to convert from a number into a string, right? If I put something in quotes like hello world, I don't also need to say take this thing that's in quotes, so is a string. I don't need to say also turn that into a string. It's already a string. It's fine. I don't need to do that kind of work. It becomes redundant to say take a string and make it into a string because it's already a string. We don't need to give that extra instruction. It won't break anything, but it's redundant. It's extra work that makes things confusing and hard to read and causes more problems down the line. Similarly, if my 511 is a number, I don't need to say make it a number or create. We're not saying make an int that is the value 511. This says take this 511 that is an integer and then make it into an integer, right? So this str parenthesis, this int parenthesis, these functions work is actually modifying, is saying make a new version of this value that has this different type, and we only need to do that if we're actually interested in changing the type. In practice, the only time you'll do this str is if you're trying to take a number and concatenate it with a string, like with our course LIS511 type thing. That's the only time you'll use the str. The only time you'll use this int function is if you're trying to take a decimal value and convert it into a whole number value because you want to do that to like round it down, for example. Okay, the last thing I want to note about strings is you need to be really careful about where these quotes are, right? Quotes are what are used to indicate that something is a string that's actually text. For example, this is saying I'm going to create a variable called department, whose name is going to be LIS, and then I can print out that department, right? So if I print that out, I get LIS that shows up here. Now, to be really clear, if I put this in quotes, if I said print department, now I'm not referring to this variable name anymore, right? This is not referring to the label department. Instead, I'm referring to the string department. So if I say print out the string department, it prints out the word department, not the value of the department label. So a string is an actual set of text, whereas a variable is actually the label on that text. And those two things may or may not match. Similarly, if I'm trying to say department is equal to LIS, right? If I want to say take this label and I want to assign it some text LIS2 here, we'll make this go back to where it goes. If I try to run this code, I'm actually going to get an error here where it says that there is no thing called labeled LIS. So because I haven't put quotes around it, Python sees this LIS and thinks that's a variable name. It thinks that that's a label, and it goes looking for saying, hey, who here's got the name tag LIS? Anyone here called LIS? And it can't find anybody. So then it gives you an error, right? That's not defined. No one was named that. I didn't know what to do with it, and the whole thing breaks. If I want to be talking about text, I need to put it inside of quotes. Now I'm not talking about the thing called LIS. I'm talking about the text LIS, which then I'm assigned to a thing called department, not the word department. So being clear about whether you're talking about text, right, in quotes, right, a value, right, it's a string, or whether you're talking about the label on some data, right, the name tag for data, which is a variable, you need to be sort of careful and clear about which one of those things you're dealing with, right? If I say print department, this is saying print the thing called department. It says print the thing that is labeled with department. If I say print department, then this is saying to print the word department. I mean, I don't know how, here, I'll put like backticks around it. All right, that's how we're handling that. Those are two different things, and that's the thing you want to be careful of. In programming, and you'll see this with more and more as we get through programming, every piece of punctuation matters. Where those quotes land becomes really, really important. So be very careful and very clear about how you're doing that, whether you're talking about a string or whether you're talking about a particular value. Okay, so that covers the basic data types, right? Numbers and strings. That should get you through the sort of the first couple exercises at the beginning of what we're doing through the course. We'll introduce more data types as we go forward and as we need to do more stuff with them, but that will get you enough to be able to like do some work with numbers, so some math, do some work with text, so do some text processing. That should get sort of getting started for where we need to go. And as always, if there's any questions, definitely check in with us about sort of how these variables work, and hopefully this will help get you where you need to go.